Meat, before it's ever meat, is a muscle. And muscles, of course, do the work for animals. Now, when you look at the way muscles are structured, they're basically a series of cables. Tiny little cables woven into bigger cables, woven into even bigger cables. You may not think of them as cables, but in fact, that's how they work. These long strands of muscle fibers contract. That's what allows you to move your muscles. It contracts in one way, or it relaxes and other muscles contract and you move in another fashion. And all of that has to be very strong, because if the tissue didn't have lots of strength in it, you couldn't actually do any of these things effectively. It would tear. The molecule that makes that meat strong, or the primary molecule, is something called collagen. Collagen is a polymer. That means it's a molecule made up of many repeated parts. It's a long chain. You can think of it like a lot of Lego bricks stuck together. And these polymer molecules are long molecules are wrapped around each other and around other components of the cells in the muscle to make it work. Now, collagen is critical for us because collagen is the molecule that makes meat tough. And it's got a couple of other interesting properties. The first is when you heat collagen above a certain temperature, it starts to contract. So if you've ever cooked meat in a pan, you'll see that juices sizzle out of the meat, and if you watch carefully, the meat actually contracts and shrinks. And the hotter you make it, the more it's going to contract. That's because the collagen is shrinking. When that collagen shrinks, it effectively forces that liquid out. It's almost like wringing out a sponge, except instead of wringing it by externally happening, it's wringing itself out. The sponge is collapsing and crushing itself, squeezing moisture out. Now, the critical temperature for collagen shrinking is about 140 degrees Fahrenheit, 60 degrees centigrade. Below that, you get very little shrinkage of the collagen. Above that, it starts to get worse and worse. So if you want to have your meat juicy, the meat really needs to be 140 degrees Fahrenheit or below. If you make the meat hotter than that, you're going to cause a lot of collagen shrinkage, and you're going to wring the juices out of it, literally by mechanically squeezing it. So that's one of our big considerations. But we have another one, which is to make tough meat tender enough to actually eat, we have to weaken or break a bunch of those collagen molecules. Now, one way to do that is to do it mechanically. A cube steak does that. Hamburger does it by grinding it up. Maybe the most interesting one is something called a jacquard, which is a tenderizing device that has 48 tiny little blades that come, they're about 1.5 millimeters, 2 millimeters wide. They come and they cut little bits of the muscle fibers. And they nick it and cut others, but without cutting the meat totally. So it's not like a slice. It's just poked a bunch of holes in it. Well, jacquarding does two things. First of all, by mechanically weakening a bunch of those collagen cables, it makes it easier to bite through, so the meat's more tender. Interestingly enough, jacquarding makes the meat juicier. Now, that totally is counterintuitive, because you think if I poked my meat full of lots of holes, how could it possibly be juicier? Well, the answer is by poking it with those holes, you are weakening the collagen fibers so they don't do a less effective job of squeezing the moisture out of the meat. When I first discovered this with a set of careful experiments where I would weigh the meat before and after cooking to see how much of the juices had left and cooked it at different temperatures, I was shocked. But in fact, poking your meat full of holes can make it be more juicy if you're going to cook it. Well, the other primary way, besides this mechanical cutting of the fibers, is to degrade the collagen. When collagen is heated in the presence of water, it undergoes this reaction, and it turns into another familiar protein, gelatin. That's why if you have a veal stock or a beef stew, and you put it in the refrigerator, it sets up hard. that is gelatin, and it's gelatin that came from the collagen in the meat turning into gelatin. Now, that process occurs at a certain rate at various temperatures. Collagen naturally unravels a little bit even at normal body temperatures. So most mammals have a body temperature of about 100 degrees Fahrenheit. You know, humans, we say 98.6, but close enough, 100. At that temperature, collagen is constantly winding and rewinding, but it's not making an irreversible change. As you start bringing the temperature higher above what that body temperature is, you start making these irreversible changes where it goes to gelatin. Well, traditional cooking will do this by the way of heating it. For example, in a braise, or in a stew, or to extract stock. So you heat it in the presence of water for long periods of time. You might braise it, for example, for 4 or 5 hours at just below boiling temperature. That is a very effective way of breaking the collagen, and so braised meat is tender. Unfortunately, it's also dry and gray because typically you're braising it at 180 to 190 degrees Fahrenheit, well above that 140 degree threshold where the collagen shrinks. So we have wrung our meat thoroughly out. And as a kid, I always used to wonder, how could this beef be in a stew surrounded by liquid and be so dry? Well, this is why you've actually squeezed all the water out of it by heating the collagen. Sous vide cooking offers a different way to do that. The same reaction that breaks collagen into gelatin will also work all the way down to 130 degrees Fahrenheit, even a little bit below that. So if we want to have meat seem like it's medium rare but still be tender, we can do that by long sous vide cooking. Beef short ribs are a great example. Short ribs are a very flavorful, wonderful piece of meat, but they're a little tough. If you cook them like a steak, you better slice it really thin and you better chew really hard. So that's why traditionally short ribs have been a braised dish where you braise it forever. And because there's a fair amount of fat in short ribs, you can braise it and it's still a palatable thing. It's quite different though than if you cook it at a lower temperature. So what we do is we cook it sous vide. Depending on the final result, we would cook it sous vide at between 130 Fahrenheit, 55 degrees centigrade, up to maybe 62 degrees centigrade. That's 145 degrees. That's just above that collagen threshold. In that range, we might cook it for 24, 48, or even 72 hours. Now, every one of those time temperature combinations will have a different final result. There's no one right way. This depends on what you want to achieve. Now, if you cook it at, say, 130 degrees Fahrenheit for 72 hours, you'll get a short rib that's as tender as filet mignon, but has the flavor of short rib. It's a very interesting cut of meat. It's effectively a cut of meat no one ever experienced in that way before until people developed this technique for sous vide cooking. So that's one of the ways to get around it, but what if we don't have the 72 hours? Well, a pressure cooker offers you a very different way of getting rid of collagen. The temperature at which water boils depends on the pressure. At 1 atmosphere pressure, what we normally experience, we all know that water boils at 100 degrees centigrade or 212 degrees Fahrenheit. But if we increase the pressure, we can make that higher and higher and higher. In fact, there's almost no limit to what you could do with enough pressure. A standard pressure cooker is effectively a pressure vessel that allows the pressure to go up typically to about 2 atmospheres pressure, so twice normal. And at that pressure, water will not boil until 250 degrees Fahrenheit or 121 degrees centigrade. Now, why is that important? Well, food is mostly water. Most meat is about 75% water. So we can't possibly make the interior of the meat a temperature above the boiling point unless we get the water out of there. Otherwise, the water will boil and it'll hold us at that temperature. A pressure cooker is the way to do that. And it's important for collagen because we can speed up those collagen reactions enormously. rather than braising in a traditional braise for 5 or 6 hours, you could probably accomplish that in 30 minutes, 20 minutes even, in a pressure cooker.